All right, up next we have Paul Ebersman, who's with, works for Infoblox in the IPv6 Center of Excellence as a technical resource for both internally and to the internet community. He also happens to be on the California IPv6 Task Force. He's worked on the internet for the Air Force, started working on the internet with the Air Force in 1984, a long time ago. And he was employee number 10 at UUNet and helped build AlterNet and modem network used by MSN, AOL, Earthlink. He's maintained his roots in the internet and open source community. He's worked at various internet infrastructure companies, including ISC, Nomium, before working at Infoblox. And take it away, Paul.
Thank you. All right, so I'm going to talk basically about the things that are different in IPv4 and IPv6. I'm going to assume that everybody here has played with this for quite a while. The things that we always hear about that are different in IPv6, of course, is lots of addresses. Huge, large. Some of the things that you may not expect if you haven't been playing with it as much is, as Jeff was talking about, you wind up with lots of addresses on every single network interfaces. IPv4, one address, one interface. There's also a lot more magic that happens. Things that happen behind the wires. Things that we are talking about, DHCP and RAs, work in ways that we have not seen before and do not expect. The folks that have a lot of experience in v4 have been the ones that have, or in dual stack, have been doing it with routers. They've statically configured them, and they don't do RAs. They don't worry about a lot of those things, and it's been very straightforward, and that's where we have the largest amount of operational experience. What I'm going to talk about are some of the things that you need to think about as you're planning your rollout that are different and that move further up in the stack. Those of us that have to play with hosts and servers and end devices, that's where a lot of the more icky parts of our networks are going to be a challenge. So the basic picture is straightforward. Nothing really much changes above and below the IP layer. And at the very most basic level, IPv4 and IPv6 do the same thing. There are some things that have changed in routing that are definitely going to make our lives better over time. Has a fixed header size now. It's no longer a variable length header. All of the options are in an extension header chain, and all of the route-specific options are at the beginning of that chain. So if I'm writing routing code, I immediately know how much to snap off the front of the packet, and when I start walking through the extension chain, the first non-router extension I see, I can stop parsing. That means that I can get through that packet a lot faster, and my code can be much more efficient at the point at which we have v6 in the ASIC and we don't have to worry about routing v4 on that particular link. They're flow labels. Guy talked about them this morning. Biggie, there's no fragmentation anywhere in the network other than from the originating host. We use PathMTU discovery instead to decide how big the network pipe is. Good news, of course, is that this means that all of those middleware boxes that thought that they had the right to play with our packets and do unfortunate things between the source and the destination and got fragmentation wrong no longer get to do that, nor do they have to do that. Of course, the other side of that is that now we have OS stack programmers who have never written fragmentation code because they've never written network boxes doing fragmentation code. So expect to see a lot of the same bugs, but see them in different places. There is no checksumming in IP now. There's checksumming in other places, so we don't have to have that overhead in the router. There's some things on our network that means there's going to be less crap floating around. There's no longer broadcast. Things are in multicast groups where you subscribe to the traffic that you wish to hear, or you offer services that other people need over particular well-known multicast addresses. There's no longer ARP. There is something similar with solicited nodes. And ICMPv6 has been really redesigned. It's much more surgical and precise in the functionality than ICMPv4. So because of all those things, that means that there's less crap floating on the network. One caveat, though, is that it's still a broadcast domain. We may be able to have 18 quintillion IP addresses available on a /64 and a subnet. But because it's a broadcast domain, anything above the 2,000 to 4,000 actual entities speaking on that wire, and there will be enough ICMP and multicast traffic that it will start actually eking out real data. So we can't really have more hosts on the network probably than we're doing in v4 for similar traffic patterns. We simply won't run out of addresses first. There are 3 basic types of addresses: unicast, single sender, single receiver; multicast, single sender to multiple receivers. Anycast is really not a type, but it's usually put in this list. This is the same trick we do with Anycast in v4. This is where you inject a specific host route into your routing infrastructure, but you have multiple physical boxes that all will respond to that address. That's how a lot of the CDNs work. That's how most of the root servers and TLD servers work, so that you can have somebody that's topologically close to you in the network with the same IP address, but have multiple hosts. v6 works just the same. For any type of address, which says, am I sending one-to-one or one-to-many, there are scopes in which that address is valid, domains in which that is the use for that type of address. The first one you'll see is link local, which is on that wire. In this context, it's really not technically correct to call it broadcast domain, but it's close enough to useful. It's the single virtual wire that you have on a single subnet. And so for most of us, broadcast domain has the right baggage to get that concept across. Global unicasts are public routable addresses that are guaranteed to be unique across the entire internet. This is what we finally have enough of again, and that most of us will be using most of the time once we leave our single local subnet. There is unique local, which is more or less the 1918 equivalent. There are several transition and address styles. Most of them are on their way to being deprecated or deprecated. And there's various other things that you may see. Go ahead and read the RFCs, particularly if you're having trouble sleeping at night. But you're not going to see them in most cases. You're not going to have to deal with most of them day to day. Linked local is where you start. It is your virtual wire, and all of it sits in that address range, FE80. When you go to any host anywhere that has an IPv6 enabled interface and you look at the addresses it has, that's one of them. And that's the one it has to have. That's how it talks to its default router. That's how it discovers its own address. That's how it gets all of its services. Another cute little gotcha. Your default route is to the link local address of the router on your network. It's very similar to a PIPA in that if you came up with DHCP in v4 and there's no server, you can try and use this subnet and see if you can get to anything locally and then talk. So you can, if there are no routers on the network and no other services, still potentially have the useful experience on that local wire. Another one that's a little interesting is that your link local is basically your self-derived address, which is usually the EUI64, based on your MAC address, slammed together to FE80. Most hosts that are multiple interfaces will still usually use the same MAC address for the same host. Therefore, your link local could be the same on every interface you have. The way they differentiate it is there is a zone or scope. So if I have 3 Ethernet interfaces, EN0, EN1, EN2, what I will have is my FE80 : my EUI64, and then depending on the OS, for some representation, frequently %EN0 or whatever, so you can use that to actually specify what interface you are using. Global unicast addresses are what I personally recommend that you use for everything. We can get enough of them, and I'll talk more in subnetting about why having enough addresses and using the same scheme is a good thing. It's something we've wanted for years and could do again. They are unique, they are routable, they are public. I think you should probably use them everywhere. Unique local is like 1918. Any polite router that sees unique local, and there's a specific address range for unique local, should discard that and not ever route it past your enterprise. But in the odd concepts of the world, it's supposed to be for you, therefore it's not guaranteed to be unique. Just like Net 10, everyone in the world has networks that are on net 10 or on 192.168.0 or 1. If you combine two different places, the odds of having address collision is huge. So 6X, one of the tunnel providers out there, is offering a service where you can register your unique local. So your private, not to be used by anyone else, only for internal purposes, can be registered so there's no collisions. This makes my head hurt. I am a big believer in, if you want to filter that stuff out, filter at the edges, use global unicast everywhere, and let your security devices do your security device stuff like they're supposed to. Don't try and depend on the kindness of your ISP to filter your unique local and protect you. But I also know, because we have customers like this, there are many requirements that drive using NAT and 1918 at layers 8 and 9, and none of those are going to go away because we have changed something at layer 2 or 3. So, because we have all these addresses, we get to use them in ways that make sense. Go ahead, use them all. It'll work great. And every client stack is capable of dealing with the fact that it has multiple addresses. We can have clients have multiple default routes, and they will rank them, and it will appropriately use them and fall back to one if its primary choice is not available. One of the other things we can potentially get rid of is all of the VRRP and HSRP or running active routing protocols on our hosts to be able to give our servers redundant routes out. IPv6 has it built in. Every single laptop, every single server will all deal gracefully with this. And there's a concept of quiescence. In the old days of modems, if you were going to be doing a maintenance window, 2 hours before you were actually shutting things down, what you would do is you would turn off the hunt group, the list of phones that dialed into your modem bank. That meant nobody knew dialed in for the last 2 hours. And what you did was you waited patiently for all of those users who were going in and doing their email to drop off. And hopefully by the time of your maintenance window, all of them had dropped away, and when you turned everything off, you didn't disconnect any users. We can do that with addresses. When you get your prefix or your DHCP address, it comes with a lifetime. You use it for that lifetime, and if for some reason it's not renewed because you've renumbered whatever, it doesn't drop any active TCP connections that are using that address. It marks it as deprecated, so it will not initiate any new connections, but it won't kill any of your old ones. There is a timer, usually 1 to 2 days on most of the OSs, after which, if it's been deprecated for 1 to 2 days, it will then finally drop the address. But it means that I can renumber live, and the odds are really good that my users won't notice. I can do it during the middle of the day because they will keep using that address that's been deprecated for the rest of that business day, and by the next day, when they start up a new connection, they're on the brand new address. Could be a completely different prefix, different default route. They will never know. The question that you are probably now thinking about, though, is, okay, I've got multiple addresses. They come and go all the time. I got multiple default routes. How do I know what source address I use when I send out a packet? There is an RFC that describes this, 3484. I recommend you read it. It is rather dense and complex, and we are already discovering issues with how it works. Two things that will pop up when you hear about this. One of them is happy eyeballs, which is that BOS and 3484 may not always make the best decision. So sometimes things like your browser may decide instead what address you're sending to and what address you're sending from. And the IETF a couple weeks ago, they've already committed to doing a 3484 BIS. So keep your eyes open. This will be changing rapidly over the next year, year and a half. So subnets. You know, people talk about the fact that there's lots of addresses and that's why it's cool in IPv6. To me, the cool thing about IPv6, other than the performance enhancements, is the fact that we have enough address space that we can actually have a subnetting scheme and a network architecture and a subnetting plan. This is not what prefixes did I get stuck with and get from a merger and acquisition and buy from somebody else and glue together, and my ACLs look like spaghetti or patchwork quilts because there's no rhyme or reason, because I don't have enough address space to have my subnets match how I do my network and how I do my business. We can actually, we get to do our jobs again. We actually get to architect our networks. My recommendation, of course, is use global unicast. If you have to do NAT, even then, NAT GUA addresses on the back end. You'll have a choice. And if you can finally convince people that NAT really is not security, you don't have to renumber from ULA to GUA later. And map your network to the way you do business. If you do things regionally by data center, break out your address and your subnets by data center. If you have security zones based on what department you're in or what project you're working on, split out your subnets by project. Do it so that all of your aggregation up to your upstreams makes sense and aggregates down as small as possible, and so that your ACLs and all of your security stuff is something sane. So that when they drag you out of bed at 3 o'clock in the morning to fix something and you're staring at it, you don't have to have 12 pages of cheat sheets to explain how this stuff works. I'm not going to bother to go into this in detail. It'll be in the slides. But this is just one example. One thing I will say, subnet on nibble boundaries. Each one of those characters, the 2, the 0, the 1, the D, the B, the 8, each one of them is 4 bits or a nibble. You don't have to subnet on nibble boundaries. It will work just fine with no boundaries at all, anything between 1 and 128. But for human beings, if you subnet within a nibble boundary, you're splitting that letter, and it's much harder to do and much harder to read. Go ahead and split it out the way you want. This is a geographic zone. So I only have, say, 8 cities. So I know that 16 possible cities is enough for me for growth, and I can do that in 4 bits. And in my case, because I am doing regional data center, I'd break it down. Each city would have a certain number of actual hubs or data centers. There might be multiple floors within a data center. There will certainly be multiple switches within any floor. And I probably VLANing with customers in every single switch. I have actually, within my 64, specifically documented down to exactly which VLAN I'm on just from the address. So there are some things to keep in mind when you're doing your subnetting plan. There are some rules and some good ideas. One of the issues out there is much like, depending on your ISP and the rules, most will not do longer prefixes than a 22 or a 24. If you come to your ISP and say, I want you to actually announce my AS and announce my /28 to the world, they will say no. Right now, a /48 is the default size that you will get as an allocation for a company unless you need bigger. But very few people other than broadband consumer are giving prefixes longer than a 48. I am unaware of any ISP that is willing to actually peer and announce a prefix longer than a 48. So if I have 3 sites that are physically disconnected with no backbone, and each of which has their own internet connection, and I am planning to use the same prefix and have it announced from 3 places, I need to have 3/48s. And when you go to your RIR and justify your space, because Infoblox did this, we had 5 sites that we needed. We could have happily sat within 148 in terms of the number of subnets that gave us for use. But we had 5 sites. So we had to go up to the next size because we needed to be able to give 48s to all of them. So we wound up with a 44. And that's another, the allocations from the RIRs are also doing things usually in multiples of 4 to make the math easier. For pretty much anything that is an actual subnet that has hosts, that is not an intermediate routing device, pretty much everybody agrees a /64 is the size. This is also what Slack assumes. Slack assumes that the right 64 bits is the host ID, the left is the network, end of discussion, full stop. As a matter of fact, if you try and pull your subnetting into that rightmost 64 bits, there are broken stacks out there that will not like it, and it does break Slack because Slack requires that you have a 64-bit host identifier. There are some exceptions to why you would use a /64. The most notable one is point-to-point links, where there are only 2 entities. There is an RFC about this. There are some people that will recommend that you use 64s even for point-to-point links because there's plenty of address space, who cares, and it makes everything the same. The issue, and if you read the RFC, they'll give more details, there are some things with neighbor cache corruption and with ping pong attacks where even though there are only 2 boxes on that wire, you can still do various ICMPv6 stuff and potentially melt or severely degrade the performance of that point-to-point link by having lots of these crap packets. If you make it a 127, the protocol stack says, I only have 2 end hosts, I will ignore all of that stuff because I don't have to do it. You will see some providers still doing 126s. Most of those are from the period of time before this RFC was put in place. The other thing you'll see is 128s for loopbacks. If you were doing active routing protocol and you were using /32s for a loopback address within your routers for BGP, ISIS, OSPF, 128s are the same. The other nice thing about doing it this way with 127s and 128s is if your backbone and your NOC are already used to the concept of everything is /30s and /32s, they will look at this and they will go, the number changed, the concept's the same, and they will be happy and they will not be confused. You should give a /64 for all of the /127s or point-to-point links within a routing area and a /64 for all of the loopbacks within a routing area. Be careful and make sure you do it per routing area. If I have 3 sites that are not interconnected, I do not want to use the same 64 for the point-to-point links within each of those because I've then segmented my network. So one of the things I get asked a lot is about multi-homing and gee, we weren't really sure what to do and should we get provider independent space or ISP assigned space and should we get an AS and should we get one number and announce it in multiple RIR's regions or get one from each RIR. And the good news is that if you understand how to do that in v4 and you're happy with all of your decisions, you can do exactly the same thing in v6. Bad news is that if you didn't understand it in v4 and were hoping that v6 would somehow magically make this clear to you, no dice, it's the same problem. Hire a consultant. Slack versus DHCP is probably the biggest thing that you will notice in v6 that you really need to understand the details on before you start designing. With v4, basically you can manually configure a static interface, or you enable DHCP, and when your box comes up, it just starts spewing. It does the DHCP discover, looks for the offers, goes through. That's your choices, that's how it works. In most larger environments, broadband consumers, large enterprise, everything else, the world is centrally managed. There are a relatively small number of DHCP servers. There are relays from all over the network from each subnet that forward those packets on. And if you want to sort of validate your network and your security policy, effectively that's looking at your DHCP configs. And what you do is you go to your DHCP server, you look at your configs, you see how it works, and you're done. With IPv6, there is Slack. And even if you don't want to do auto configuration, and we'll go through some of the other choices, you still have to process the packets. You can, in theory, turn off listening to RAs, but it's usually not a great idea, and it's complicated. So what it means is that network policy is no longer looking at your DHCP server. It's now looking at the RAs as well. And every single broadcast domain, every single subnet, each VLAN, virtual interface, each physical switch port, each router port is now potentially homing a subnet, and every single one of them has to be configured to be an RA and has to be correctly configured. And as Jeff's talk shows, consistently configured. So it's no longer sufficient to look at my DHCP config. I have to look at my DHCP configs and every router and every switch port everywhere in my network. And you have moved that network policy from the central DHCP potentially to all of the edges with no centralization. You could do no DHCP at all, with a couple of caveats that we'll talk about, and let every single subnet do its thing. It does work. It is a possibility. Now, as far as how it works, Jeff has covered it pretty well. I'll just go through really quickly. EUI64 is basically permuting the MAC address, turning it into 64 bits. That is the most common way that most hosts will do their host ID, the 64 bits host portion. Windows 7 and Vista in client mode will use the randomly generated by default. You can go in and change it in the registry. Otherwise, most of what I see on most Linux and Unix and servers, if they do all of this, is they will do it with the EUI64. And yet another picture to add to your collection of explaining how it gets cut apart. The way you go through, I want to step through the sequence of getting an address and getting configured because it's important to understand the pieces. The first thing that I do as a client when I come up is I generate my host address, my 64 bits, either by EUI64 or by random, however I'm configured. And then what I do is I take that and I take FE80::, which is the link local. I slam my EUID onto the end of that. And then immediately thereafter, I have a temporary working legitimate layer 3 address. What I then do is make sure that I can actually use that. Because we all know stories of, you bought some Taiwanese set of computers with network cards and discovered that they all have the same MAC address, which means if you're doing EUI64, you might have 12 machines that think they have the same link local. So what you do is you send out an ICMP multicast message, a neighbor solicitation that says, I'm about to try and use this link local address. Is anyone else using it? And I send it to the all nodes multicast address, which means that any node on the network is supposed to be listening. Therefore, if anybody's using the address, they will respond with a neighbor advertisement saying, not so fast, I'm already using that address. If nothing happens, it keeps the address. It moves it to actual permanent or usable status. If it doesn't, what it does is it does it, depending on the OS, it has some algorithm for randomly modifying that EUI64, takes that new host ID, slams on the end, does duplicate address detection, and if nobody answers, he has a good working address. At that point, I have an actual real usable IPv6 address. This is no MAC address, no broadcast all zeros, none of the other funky stuff we used to do in v4. I can then send out a router solicitation, which is another ICMP multicast message that basically says, hey, I just came up, I'm on the network. Do I have any routers that can give me information about my network? And then it sits there and it listens for router advertisements in response to that router solicitation. One of the niceties, it's a multicast. I send that router solicitation to the well-known multicast of all routers. So none of the other hosts on my network have to care about or listen to that. I'm multicasting it specifically to them. And then if there are router advertisements, I have a real address so they can unicast back to me, here is your response. If I get nothing, I wait around a few minutes and hope that somebody responds. And then if not, I just go off and I have my PIPA equivalent experience because I've got no router, I've got no DNS, I'm just sitting on a wire. Hopefully I get one, and what I do is I then parse through all of the flags on that RA message that tells me what I'm supposed to do and how I'm supposed to configure myself as a polite citizen on this network. So the RA has a bunch of stuff. The most obvious thing in some ways has whatever prefixes are available to be used on that network. And if the A flag is on, it says, here's the prefix, and you can give yourself an address using that same host ID you have for link local. You can just slam it onto this prefix and be happy. Now, I can get a prefix announcement with the A bit off. What that tells me is this is the prefix for my network, but I am not allowed to actually give myself an address. It has information about the router who is giving you this information. It's link local address, which becomes my default gateway address. That's my next hop. I may have a destination address of some GUA IPv6, but my next hop is going to be the link local of my router. And it's going to tell me how long I'm supposed to keep that before I refresh or change that route, and a priority. So if I get multiple RA messages, I will sort them by priority, and the one that has the most desirable priority will be the one I will try and use. If that one stops working, I will go to the next most desirable. And then finally we get into the DHCP stuff. M says managed address. Get an address from a DHCP server. O, other configuration. Little gotcha. you can, as Jeff said, assume that if the manage flag is on, that the O flag is on. Actually, what it says is that the M flag is on, the O flag is no longer relevant because no one sane should ever have M on and O off. Unfortunately, there is a company who actually followed the protocol spec exactly. And if you set your RA to M on, O off, it will do exactly that with all of its clients. So, for best practice, if you turn M on, you should always turn O on, even though it's really noise. Now, for classic DHCP v4 experience, and a centrally managed one where you are doing some kind of IP address management, you're doing dynamic DNS, and you're actually tracking your users, what they're usually going to do is they're going to set out a prefix, but they're going to say A bit off. Do not put your own address on. And M and O will be on. Get everything you need from the DHCP server. So what will happen is I will have gotten my own link local. I will have validated it that it was unique with DAD. I will then go and ask for router advertisements. I will be told, here's a prefix, but don't give yourself addresses. I will be told I need to DHCP for everything. I will do my DHCP. I will configure. And I am now up and running on the network. Last thing that's in the RA is the MTU, the size of your upstream link. And that's simply so, yes, path MTU discovery will take care of the fact that if my upstream router only has a 1280 maximum packet size and I start sending out packets at 2K, everything I have is going to immediately be flagged as packet too big, and I'm going to have to resend the first packet for everything. Much more efficient to know that I shouldn't even bother to send packets bigger than 1280 if my router will never get them off my net. Things that aren't in the RA, though. If you are doing a Slack-only experience, one of the things you will be missing is a recursive DNS server, which if you have memorized all of the IP addresses, quad A and A, of all of the sites you care about on the internet, I suppose might not be a problem. Most of us would not consider that a usable configuration. You also don't get all of those other things, NTP, TFTP servers, all of the other stuff. Well, the guys that liked Slack in the IETF did concede that not having a DNS server was a less useful user experience. So there is an RFC that now says you can, in your RA, hand out a recursive DNS server. Unfortunately, that's in the servers, and pretty much all of the RAs at this point do support that option. Client support, though, is trailing. That's I could do the old show the hands. How many of you still have an XP box somewhere in your network? Yeah. And how long ago did Microsoft start coercing, begging, and everything else to get us to get rid of those? Years. So unfortunately, again, if you want to be a good production citizen, you need to assume that you must hand out DNS servers via DHCP. So we're stuck. We will all be running RAs because you don't DHCP unless you got an RA message with the O and the M or O or M bit on. There are people who argue that that was not explicit in the RFC and that therefore it's okay to just start DHCPing without getting that, but that is not a widely held opinion, and that is not how most of the software has worked. So you need an RA to say do DHCP, and you need DHCP to give DNS servers. And there are lots of stuff that we have put into DHCP over the years that we need. The other advantage with this is that once you've validated your config on all of your RAs, on all of your switch and router ports, unless somebody changes something, and hopefully you have some kind of router configuration monitoring software, you set it up once where you basically you throw out the prefix, you set the A bit on or off, you set O and M on or off, however you want, and you're done. DHCP has definitely improved. Biggest thing as far as I'm concerned is it's not bootp. Everything else beyond that is gravy. DHCP v4 is a hideous protocol, and it has been abused, bent, and twisted over the years in unpleasant ways, and all of our DHCP servers suck because the protocol itself is a fundamental mess. They took care of a lot of those things. There is no broadcast because by the time you do DHCP, you already have a link local address that will get you to your server. You have a real genuine IPv6 address that is usable and unique. And you can send to a multicast address that has all the the DHCP servers and DHCP relays on that network. Nobody else has to be bothered by the traffic. So no broadcasting to everyone in the world. You just multicast, and the server can immediately unicast back to you, even with the initial advertise, because you have a real IP address. Put it on different ports because you have to run both, just like we're running v4 and v6. You have to run both of them in parallel because they are not compatible. Therefore, you have to run v4 and v6. Currently, no server runs both. You have to have two separate server instances, two separate lease files, all the rest of it. So there's different ports so you can do that. All of the options, and of course this was where much of the baling wire and duct tape went, was vendor options. It's now done as type length value tuple. And it's a very generic but very clear format. So we have neat, clean, shiny plastic buckets to put all of that crap from the vendors in. And at least we can stack them neat in piles, and we can write code that shovels through them fast. Reconfigure is now much more secure because you can use an authentication protocol. It is not just anyone on the wire. So if you choose to enable that, because of the fact that there is quiescence with the clients and they happily will deal with multiple addresses and gracefully switching from one to the other, and you can actually do a push from your DHCP server, renumbering can not only be done live, but it can actually be done very quickly. I won't go through this table, but it's a good reference. It basically maps the v4 message that you are used to and what are the equivalent. The only thing I will say is one of the nice things, again, is they've actually broken things down. You can actually now tell that it's a brand new request for DHCP address, that it's renewing an existing lease, or rebind, which says, I was powered off, I powered back up, my lease is still valid, but let me make sure that the network hasn't changed out from underneath me. You can actually break those all out separately and know in your logs which are which. So much better statistics of what your DHCP traffic is. So, other arguments to be made. Everyone says, gee, 64s are huge, brute force scanning is a thing of the past, it takes years. And it does, assuming that you are actually using the whole 64. Now, for my servers, I was lazy. For a server of 192.168.0.10, I took my prefix and said prefix : 10 is the IPv6 address on the same server, because it's easy to remember. And for a server, I don't care. It's in DNS, I'm advertising it, I want people to find my server. So the fact that they can brute force scan and discover that my server exists, congratulations. But if I do that, I have now reduced my 18 quintillion possible addresses on the subnet to 254. So I have taken away all of the advantage of having all of that address space. So on your pools, use the whole 64. The addresses will be ugly because they will be random on both sides. You will have a full 32 characters long of alphabet soup, but it will be much more secure. And we no longer have the issue of, gee, I'll give 20 addresses here and I'll split the range and I'll put 40 over there because I don't have a whole lot of v4 address space to give to my DHCP pools. The days of running out of addresses in a pool should be over. If you exhaust 18 quintillion addresses in your pool and in theory your network is still actually usable, your pool size is not the thing you should be concerned with. And further, if you are actually noticing that your lease file is getting even vaguely up to 18 quintillion, and do the math for how big a disk file that would be, I pray to God that you would notice before that got out of control and you exhausted the pool. Yes. So, reconfigure. You do have to configure both sides. The client must be willing to be reconfigured, and it must be configured to do so. The server must be able to do this and must be configured to do so. But it does at least now have security. It's a good thing. The other thing that is going to chafe us is the IETF said MAC addresses are evil. The fact that 99% of the world looks in the leases file and that functionally the key for the lease for the client is its MAC address and that obviously the world hasn't come to a screeching halt. We haven't created a black hole. Obviously, it's workable. That wasn't good enough for them, so they decided that you needed a DHCP unique identifier, a DUID. I like the concept of the DUID because one of the things is that the MAC address, as we've already said, I can have multiple NIC cards, all of which have the same MAC address. So in IPv4, the first interface that does DHCP wins. I can't use DHCP for any of my other interfaces, which sucks, because most of us these days have laptops that have at least hardwired and wireless and frequently cellular, and we're not even a server. So it's nice to be able to use DHCP on all of them from the same DHCP infrastructure. So yes, the MAC address, it's not guaranteed to be unique. You can have duplicate MACs. You can alter it in software. And multiple interfaces don't work well. Sure, you're right. But obviously it's been working for us. Well, okay, fine. They didn't buy that. They created the DUID. Yes, MAC addresses suck. DUIDs suck differently. Because in v4, the reason that you use the MAC address is because you use your MAC address and you broadcast to all zeros. And if the server gets it directly, it now knows your MAC address. If a relay gets it, it takes that and shoves that into the GIADDR field in the relay packet and hands it to the server, and the server knows your MAC address. You don't have to do anything special, nor does the client, to know who that is. So that's how we know this particular MAC address is this v4 address. Well, DUID is generated with something that vaguely relates to the MAC address, but it is not. And the RFC specifically prohibits you from, how do they put it? It is an opaque object, and you must not attempt to infer the MAC address from the DUID. So I have a DUID completely unrelated to the MAC address and no way to know that that's the same client. There is a draft going through to insert MAC address into the relay packet in v6, and it is looking promising, but it is just at working group status. It will be a while. Until we do that, we're going to have to do other clever things to correlate those addresses. Something else to keep in mind if you were a system administrator. In DHCP, you take a lease, and as a client, you usually have, on Windows Box, you'll have a registry entry that has your lease. And if you're using an ISC-based, which most of the Linux do, it goes into your own leases file on your hard disk. DUID is the same. The first time that you DHCP as a client, if you do not have a DUID already, you will generate it and you will put it into disk. If you then ghost that machine, you ghost the DUID. And it's the same thing as a duplicate MAC address. The things that it does right, it's unique, client and server. You identify the interfaces with an identity association. Every network card will have an identity association. The pairing of a DUID and that IA is what makes a unique identity for that client in DHCP. And you can read this later. Temporary address, i.e. privacy addresses. You can get privacy addresses from your DHCP server. You can get non-temporary, which sounds a little clunky to me, but which are not privacy, i.e. regular addresses that we usually use. And prefix delegation, which is handing you an entire usable subnet that you can then further subnet. Prefix delegation is really cool. It's very likely to be used in the relatively near future on CPE devices. The HomeNet working group in the IETF is working feverishly on that. Lots of potential. Really great idea. You could have a hierarchical network magically configured via DHCP from your service provider in your house in a way that a normal user could get benefit from. But right now, the standards are not set and the hardware is not there. ICMP, the big lesson here is you have to have it. You cannot filter it all. You need to have it for all of these things. Duplicate address detection, finding your routers, finding your DHCP server, doing path MTU, doing echo tests, all networking errors, all packet too bigs. So basically, if you completely disable ICMPv6, you can't get addresses, can't guarantee unique addresses, can't find your router, can't find DNS. So if you consider that a useful experience, more power to you. but it's basically the bad version of a PIPA. There is an RFC that actually is excellent. It explains those things that you really must have in any sane network, the things that are probably a good idea for a lot of people, and the things that, unless you have a really compelling need, you probably don't want on. And it's really nice. I use this very frequently in reference where I talk to security people and they want to know why or how the rules. That's how I do it. Most of the things that we are going to see are analogous. Rogue RA, rogue DHCP server, neighbor cache corruption, ARP table corruption. Denial of services are mostly the same. Most of the things, the name may change, the protocol may be slightly different, but realistically speaking, most of the risks are the same in v4 and v6. The consequence of that problem are similar, and the remediations are similar. I'm expecting to see far more misconfigurations than malice. For right now, most of the things that most people are going to use are all the denial of service and sheer packet swamping and amplified DNS and all of the other things you see now. That's what these guys are going to use because it's easier. It's work to actually learn v6 and figuring out how to break it. There are some v6 attacks in the wild, but I just haven't seen a lot of them. And obviously, we need to make sure our security stuff is up to stuff and that we have the experience and the necessary knowledge and experience to not make mistakes. And we've talked about these, for the most part, privacy addresses, so they can't log where you are everywhere. Subnet size, use the whole thing. The big one, last one, is IPsec. Everyone says IPv6 is cool because you have security built in. Yeah. The good news is that if you are already doing pairwise IPsec tunnels in v4 where you hand configure every client and you hand configure the tunnel termination point, and you have a way of doing that, congratulations, because you can now do it in v6. That's the good news. The bad news is there isn't anything better than that in v6. They cannot agree on a PKI infrastructure, so everything must be pre-configured with symmetric keys. The only exception, Microsoft's Direct Access product, and that's because they are leveraging the AD authentication, which is Kerberos. So once you log in with your Windows domain credentials, you can be given other secrets. And that's all the stuff you should be doing. Questions?
Did I understand you correctly that you're saying there's no implementation of DHCP v4 and v6 on the same box? It has to be two different boxes?
No, you have two different daemons. Much like in the early days with DNS, you had to have two separate, but now they're bound to different ports, yes.
You know, I was just curious on the best practices. Like if I'm on a Windows box or a Unix box, hard coding my address on there. I've always done for like my default gateway 2001 ABCD::1. Should that be FE80::1? So what's the best practice? And like, what if someone's just hard coding that? What should they do?
Well, it depends on what your concern is. As Jeff pointed out, if you hard code the IPv6 address, the GUA address, it will work, but redirects won't work. On a server network, I actually consider that a feature. If I'm doing a server farm of 4 or 5 web servers, my best practice is I actually do the syscoddles so it stops listening to any RAs because I don't want somebody to be able to shift my default gateway on me unexpectedly. I statically configure all addresses. I do no SLAAC, I do no DHCP, and I hard code a static route to the IPv6 address of my gateway. For that. Now, that said, what I've given up, among other things, also is if I'm doing that, I'm not taking advantage of the multiple default routes with RAs. So usually I'm doing that also in an environment where I already know that the thing I'm hard coding to is a load balancer.
So when you statically code that, do you statically code 2001 or FE80?
I would statically do the GUA, not the link local.
Yeah. Okay. Thanks.
You mentioned earlier that the longest prefix advertises /48 right now in terms of what's being advertised.
Yes.
I've heard rumblings over the last couple of weeks that might change because there's concern of prefix proliferation and memory sizes on routers, and that actually might move to a /40. Have you heard anything like that, or can you comment on that?
Yes, I've heard it both ways. My take right now is just look at the math. There are about 400,000 routes in the default free zone. and about 40,000 ASs announcing those routes for v4. There are currently, for that same 40,000 ASs, 70 or 80,000 IPv6 prefixes. The average, the last time I saw it, and Owen tracks it and usually has a pretty good slide for it also, average of about 11 prefixes of v4 prefixes announced per AS, and 1 to 2 in v4, or sorry, in v6. And the reason is that you don't have a patchwork. You can actually get a big enough block that you can use it everywhere. Now, what that does mean is that if I get a /36, say, and I give chunks to my North American site, my Asian site, and my European site, and I actually have them announce it through their own providers in their own regions, I've added 3 routes to the routing table. But in the current model, what usually happens is I'm splitting my v4s anyway, and I've gone down from 36 to 3. So when you put that together with the routing efficiencies that happen with processing v6 packets, and a lot of backbone providers are going to start doing v4 closer and closer to the edges so they can run pure v6 in their core and get those efficiencies, I'm expecting that we may hit a bump somewhere in the middle, but I don't think we're going to ever exhaust it. That I think we will be cleaning up old cruff. So my expectation is there will be enough pushback and enough technical weight showing it's not necessary. Could be wrong, but I'd be surprised.
You have the apples for IPv6 up there. I'm just wondering, with all the hosts being able to grab 3 to 4 IPs willy-nilly at a time, are we going to be looking at backing down apples and firewall rules to more network-based rather than host-based eventually?
Yeah, the question is, with all of the addresses that hosts have, are ACLs going to be moving more towards network rather than specific host base? And yes, I think that's exactly what's going to happen, because even if you do RAs with the A bit off and say don't auto-configure and you try and disable Slack everywhere, all that means is that the polite citizens who are probably not breaking the rules already won't do anything. But the bad people will still statically configure somewhere within the range. So the only same thing you can do is do it at a prefix level, not at a host level. Last questions? All right, thank you very much.